Hey guys, as promised, here we are for water transfers, getting water from here to there. Nature does it through the water cycle, streams, rivers, what have you. Humans go about it in some different ways. Sometimes we kind of share from what they do, sometimes we come up with new ways altogether. Now, transferring water from one place to another has greatly increased water supplies in certain areas. We have areas that were dry, but we're able to divert water in there, and lo and behold, we can move there. This is part of why humans have inhabited every environment on the planet, really except for Antarctica. But is our ability to change the environment wherever we go. So it's dry, we'll bring water in. It's very common to do. Once again, there are advantages and disadvantages to just about anything. And one of the ones of this is disrupting ecosystems. You know, if we're pulling water from this area over to that area, well, that area was used to having the water, so it's a disruption. Even putting water in another place, it is a disruption to whatever the local environment used to be. Well, let's look at a couple of areas that's done this a lot. China. The South-North Water Diversion Project. A lot of water flowing down into the south, and they divert it towards the north. They divert 6 trillion gallons of water per day. Yeah, that's trillion with a T. 6 trillion gallons a day are diverted from the Yangtze River system towards the north. In United States here, California, the Central Valley of California, we divert through there, mainly through aqueducts. A lot of, like almost half the vegetables grown for the United States are happening in this area. It's once a very dry, arid area, but we've diverted water down in, mainly from snowmelt from the Rockies and the Sierras. As the snow melts, that water flows down. That's what's largely being diverted, primarily through aqueducts. Now, you take a look at the picture up here of an aqueduct. Now, we've seen the whole kind of California little insert. You see it's kind of like a man-made river, right? Aqueduct is a big channel putting the water. Well, we get a lot of water loss by evaporation that way, because it's kind of in an open system flowing down, and a lot of it does evaporate back out. It doesn't make it from where we want it to go to its intended. There are leaks from aqueducts. Once again, these are man-made, etc., and water leaks out through it. And as always, there's ecosystem degradation from it. We're moving water from one area into another, and along with that comes a lot of effects. One of the effects we're going to look at is the Aral Sea Disaster. This is in Central Asia. It used to be the world's largest saline lake, salt lake, kind of like the Salt Lake City, Utah, the Salt Lakes of America. The Aral Sea used to be one of the largest in the world. Well, they started large-scale water transfers, not from the lake, but from the river systems that feed into it. So they were transferring the water into the Central Asia, where it's very dry and in need of water. Well, this led to the wetland destruction, because of the base of the Aral Sea. Once again, it's a wetland, but it's a wetland down there, and as the sea began to dry up, we're diverting the water, not enough water dumping into the sea, and the sea began to drop. And we wound up getting desertification in this entire area. We'll take a look at the picture here. 1976 on the left, down to 2016 on the right. That whole area. Now it's the North Sea, so a little tiny one up at the top. So you can see in 2016 it's still there because they put a dam on it to kind of protect the North Sea. But the South Sea has all but actually dried up. We have seen fish extinctions in the area because once again, not only is it dried up, but the lake became 3 times saltier. Not enough fresh water dumping into it. The salt remained, got saltier and saltier. That salt, now that it's dry, winds up getting blown around. Very dry area, desertification, and you can kind of see it's white on that bottom. That's just deposits of salt. Storms come by, blow the salt around, and this blowing salt can travel hundreds of kilometers. it winds up destroying wildlife and crops, because now an area becomes salty, the crops can't grow. We've even seen increased glacial melting from the Himalayas because the salt lands on the glaciers or up in the Himalayas, and salt lowers the melting point of water, and we've seen greater snow melt in the Himalayas from this salt from the Aral Sea blowing around. It has altered the local climate. Remember, water has a high specific heat. It takes a lot of energy to get it warm, but then it retains that warmth. Well, now the water's gone. So the summers in that whole area are hotter and drier. The winters are colder, and it has a much shorter growing season because the water of that whole lake moderated the climate in that whole area. The water's gone, nothing there to moderate the climate. So now the summers are much hotter and drier, the winters are much colder. Now there's been some restoration efforts, some cooperation with neighboring countries, once again, not to pull as much water out. Some of that is just going to more efficient irrigation techniques. The more efficient our irrigation, once again, something like 70 to 80% of our water use is going to water crops. But a lot of that, we're pulling the water out here, and if you're doing inefficient means, 80% of it can wind up evaporating out, or at least 50%. Depends on the area, how dry it is, lots of factors. The more efficient irrigation gets more water to the roots where we want it to be. Now once again, from the picture we can see a dike was built between the north and the southern, and this raised the level of the northern sea. However, the southern sea is probably already lost. It is expected to be completely dried up just within a few years. They were able to dike, probably save the northern sea, but the much larger southern pretty much already lost just to mistreatment and taking water. Now there's a lot of other ways we've attempted to move water. Kind of my favorite is Greece. Greece is an island and it's very populated and they don't have enough fresh water. And they've developed a system where they literally have a giant bag, so think of like a huge Ziploc. They fill it with water from the mainland and then tow it over by ship and pump it out into Greece. You can see the guys standing on top of the bag there. It's a massive system. Once again, transferring water. We've played around with trying to tow icebergs because they're just going to melt in the sea, to try and tow them areas. Once again, the problem with a lot of these is just cost and expense. We haven't found any way to tow icebergs that get them somewhere that is cost effective. So when we talk about diverting water, a lot of times it comes down to energy, and even when we build simple systems like aqueducts, we wind up getting a lot of evaporation, loss of the water, and it harms the ecosystem that we're taking the water from. Something that we kind of know, but it's a cost that we have to measure. Once again, full cost pricing. We need to stop subsidizing it and have people pay for what the cost actually is. That way people make decisions. Do I actually want to live here or not? We have to count the cost. That wraps it up for section 3. Come back next time and we'll talk about using our fresh water more sustainably. Take care, guys.